All right, so we're in lesson 114, 115. So the lesson here is about inequalities and functions and understanding which areas of the graph are true, the answers or the points in that area, which one makes both of these statements true. All you really have to do is understand which one of these stands for which one of these functions or which one of these graphs. An x squared, y squared is going to give you a circle. And this is the other clue that you have is that this is greater than without the equal sign under it, and the circle is dotted. So that's a fair clue that this one means the circle, right? And it does. It means the circle. And this one has an equal sign under it, so we know that's a solid line. So that would be the solid red line. So what we have to do is evaluate and determine which satisfies the system of the nonlinear inequalities. So if you recognize, I'm going to write it over here, x squared plus y squared is greater than 9. Greater than means the numbers are going to get bigger, right? So in relationship to the y-axis, because we usually solve these for y, the side of the y-axis that gets bigger is the positive side. So that's the up. So greater than equals above, right? It's the upper part. And that's true for circles, and that's true for any kind of shape. You're looking for the values towards the top, the above or top, right? So we're looking for the areas above the circle because this is above the circle or in the top of the circle. So for a circle, however, above is going to mean outside. So above, top, outside of the circle. So that's going to be outside of the circle is going to be either A or D, right? Because those are outside of the circle. Y is greater than or equal to X. So that means we've got either A or D is our areas because those are the areas on the outside of the circle. Y is greater than or equal to X. That tells us the line is a solid line. So we know we're talking about the red line now. Greater than still means above or top. So above, when it's in reference to a line, means it's above the negative values of the y-axis. So we're going towards the positive side of the y-axis. So the side or the area that is both outside of the circle and above the red line is going to be A. So when we select A, it tells us it's correct. That was all for lesson 114. That was it. So now we're in lesson 115. So let's look at, we are solving for these little exponents up here. So this is a base 10, so we have to turn this into a base 10. Let me make this larger so we can actually see what we're looking at. There we go, because the number was kind of small. So 27 is equal to 10x plus 5. First thing we have to do is put this in a base 10. So that's going to be a calculator thing. And I can do it on this calculator. It's not the best calculator in the world for that kind of stuff. But I could do 27 and 10x. No, that is not how I do it. It's 27. No, that's not it. All right, I'm going to get it eventually. I think it's just 27 log 10. Yeah. So 1.43. So 10 to the 1.43 is equal to 10 to the x plus 5. These would cancel. I think I'm doing that right. 1.43, we factored out the 10 basically, is equal to x plus 5. We're going to subtract 5 from both sides. So 1.43 minus 5 is negative 3.57 is a value of x. I think that's right. Let's see. We're going to find out right now if I did that right. I did it right. Woohoo! All right, so you're using your log 10 key for those. To convert this to a base 10, you hit the log 10 key and it gives you the exponent to put on 10 to get to that number. All right, now that I know that I'm not completely nuts, and I've actually remembered a little bit about logarithms, go to the next problem. So Mary deposited 980. We know how to do these. We're using this formula. It reminds us of the formula, the amount of time. So that's going to be 9 years. Compounded continuously. That's different from compounded annually. So compounded continuously is going to have the rate times the time as an exponent. And that is with an E on the E number. So finance, where you compound continuously, also uses logarithms. So if you want to go into banking and finance, there's your application for logarithms. So the principal is 980, e to the rate, which is 7%. So it's going to be 0.07 times the time. The time is 9. So that's going to be 0.07 times 9. We can do that here. 0.07 times 9 is 0.63, which I should have known. Hello. The amount in 9 years is equal to 980 e 0.63. All right, so e to the 0.63 times 980 is what we're looking for. So 0.63 trying to get it to do. Let me get my my Apple calculator. It usually does better. And it writes it so that I can see what I'm doing. I like it better. I wish it was built into the Pro Drafts. So I need 0.63. Is it this one? Yes. All right. So that's what I'm looking for. That equals that times 980. So that's going to be $1,840.06. So the amount in 9 years is $1,840.06. Is that what I said? Yeah. Let's try it. Let's make sure I got it right. I'm going to put in $1,840.06. Please be right. Nope. I did something wrong. Let's see what I did. Let me click at it. I know. Rekey. All right, I did something wrong. I got really close though. So, I know what I did wrong. I rounded it. I rounded that number, I think. Or maybe I should have rounded that number. Let's try it again. Let's pull up that calculator. Okay, so all clear. This is the full number. It's not rounded. So I'm going to say 0.63 EX equals 1.88. Let's do that. So 980, 1.88. Let's do that. All clear. 980 times 1.88. That's what I didn't do. I didn't round it. I should have rounded it. 1,842.40. Now that matches. So at least I got how to solve it correct. I didn't round it. That was the problem. So not this one. This one is what you want. Okay, so let's go back to looking at the problems. All right, this is going to be the exact same thing, right? So the number of rabbits increased exponentially. At first, there were 400. So that's our 400. 3 years later, there were 1,600. So 1,600. So the amount how many rabbits would there be at the end of 10 years? So we've got to find the rate. We've got to find that number over here that is the rate that it's growing at. So that would be ER3. So in order to find that, I'm going to divide both sides by 400. So 4 is equal to E to the 3R. So now I'm going to convert this to an E value. So that would be 4 log 10 equals 0.6. So E to the 0.6 is equal to E to the 3R. So 0.6 is equal to 3R. Divide both sides by 3. I don't think that's right. Okay, let me go backwards. All right, I'm going to go back to this. It doesn't tell me. All right, so let's see. That's why I don't like logarithms. Look, there's the answer right there. Let's figure out what we did, though. I know this part is right. We get to here, I know this is right. And I know that you have to convert this to the base of an E. I'm just not sure how we do that. I want to say it's ln. Yes, it is. It's ln. Hello. All right, so that's going to be 1.39. So 1.39 is going to be E to the 1.39 equals E3R. These cancel. 1.39 is equal to 3R. Divide both sides by 3. Okay, so 1.39 divided by 3. My rate is 0.46 is my rate. Okay, so now I've got to figure out 10 years. So we go back to the original equation. 400, so the amount in 10 years is equal to E, 400 times E, and the rate is 0.46, and that's 10 years. So that's going to be 400 E, 4.6. I feel like this is right. This feels right. Okay, so now I just pull up my calculator. I'm going to go back to my Apple calculator. So I've got 4.6 E times 400. Really close. Really, really close. So I think what I need to do is leave this in the calculator, right? So 1.39 divided by 3 times 10 that's going to be this E times 400. No, that's not right. So I've got to reduce it at some point. Maybe it should be 0.463. I don't know. 0.46 EX. Okay, so that's right. Hang on. 4.6, not 0.46. EX equals. All right, 99.48. Let's round that number. 400 times 99.48. Okay. All clear. 99.48 times 400, which is what we did previously. We did round it previously. Okay, so that's what it is. You got to round it once you solve for here. We rounded here, and then we round it here, and then that gives us the number. So the problem I have is that I type these problems from the book, and I type in the solution from the book. The book doesn't always tell me how he gets there, not all the steps. But that is the number. The amount in 10 years is going to be equal to 39,792. And with logarithms, I mean, because I don't like logarithms, I don't like to do the logarithms because to me they don't make a whole lot of sense. Anyway, we'll get there. All right, we're going to get there. Number 7. Same thing as we did up here, right? Remember this one? We put this base 10 to get our exponent, and then we cancel the 10. That's the exact same thing we're going to do here. In fact, I'm just going to do it right here. 34 equals 10x plus 3. So we're going to base 10 it. So clear this. 34 log 10, 1.53. So 1.53 is equal to x plus 3, because that would have been the base 10 here, and then we would have canceled them. So now we can subtract 3 from both sides, and then we find out what x is. So that's going to be (1.53 minus 3) is negative 1.47. So that would be the answer for that. And if I click OK, then that is the right answer. Okay. All right. Let's go to some clean paper here. Same thing, compounded continuously. $100 compounded continuously at 0.09%, 9 years. Same thing, okay, that we've done before. So that's going to be 0.09 times 9 should be 0.81. It is. That's our E right there. Okay, that equals that. Times $100. Hang on, I think we're supposed to round. So 0.81 E equals, so 2.25. 2.25 times 100 would be $225. Let's see if that's right. No, of course not. 224.79, which is what we got before. You know what I'm going to do? I'm going to add 225 as an acceptable answer for those who actually round, because I think that's fair. Because the other problem rounded, right? So I need to make it where there's some consistency there in the answers. He does not do that every time. Like in the previous 2 answers, he rounded. Why wouldn't you round this time? Just because it's money doesn't make it that much different. I'm rounding it, giving them an alternate answer. So if you do 225 here, that's rounding it to the next dollar. I'm okay with that. Okay. Preview. Let's go back to the next problem. Oh, well, hello then. That link is outdated. And all of these show up because I've rekeyed it, but you see all of the answers are the same. So that means that I didn't change the answer greatly to anybody. Let's go back to the one we were on. We just finished the second money problem right there. So now we're on this one. There's a whole bunch of these. I'll put this many problems in here. Another population increased exponentially thing. So same type of thing. The only question is, did Saxon round it or did he not round it? So let's see. So at first there were 16,000. 3 years later, so that is ER3, there were 60,000. Okay, divide by the number we know. to find the rate. So that is going to be 60, 1, 2, 3, divided by 16, 1, 2, 3, is 3.75. Is equal to E 3R. All right, so I need to put this in E format. So I like this calculator for logarithms. So 3.75 log 10 equals, oh, that's the wrong number. It should be 3.75 log 10. Is it log 10? No. 3.75 ln gives you the E exponent. So 1.32. 1, that's E to the 1.32 equals 3R. E to the 3R, cancel the E's. 1.32 equals 3R. Divide both sides by 3. .32 divided by 3 equals 0.44. So 0.44 equals the rate. How many will there be at the end of 10 years? All right, so that would be the amount in 10 years is equal to 16,000 E 0.443. And I'm here to tell you, you can type that into Google and you could say 16,000 E to the, that's what that little hood means, to the 0.443. $38,588. Let's see if that's what it takes. And here's the steps. So it says E to the 0.44 is approximately this. Then it takes that times 3. Then it multiplies that times 16,000. That's about 73,635, which looks about, so let's do 73,635. Let's see if that works. I'm just going to copy and paste. That's not right. So let's see. Why is it not right? What is the answer? Ooh, a whole lot more than that, right? Oh, you know why that's not right? Because this should be a 10. Hello. Okay, I'm losing my mind. I've got 10 here, and it should be... I've got a 3 here, and it should be a 10 here. So let me put that in here. So that would be 16,000 E to the rate of 4.4 when you multiply it by 10. So E 4.4 power is going to be, we hit 4.4 and then we do our E, that gives us a power there. We're going to round it to 2 places because that's what he has been doing in the book, is rounding it to 2 places, which would be 81.45. When you come back down here and we say 81.45 times 16,000. Okay, we get 1,303,200. I'm going to write that number down and check it. for both of our sakes. And it's a little bit off. So he didn't round it this time. That's one of the things that's very frustrating about the Saxon curriculum is he doesn't always round it. So I'm going to give the alternate answer there. And I know he didn't round it because of the 14 there at the end. So if you round it, if you're consistent in the way you do your problem and you round it, then you should get the 200, not the 214. So I'm going to allow that as an acceptable answer. Okay, so the rest of these problems, we have done them before. These are just review problems. So I am not going to waste your time on the rest, these last 6 problems. We've done them all a million times. So I'm giving you the answers, my dear. This is my gift to you this year to get you through these tedious amount of problems that are just review problems that we've already done over and over and over again. Okay, so I'm gonna quit rambling. A chemist had a container. The answer is 320 space G. Type it in like that, it'll mark it right. The next problem. A 2-digit counting number. That 2-digit counting number is 24. All right, the next problem. Use the ln key to express all these logarithms that Miss Tracy just cannot stand. You are going to write e to the 37.92. Okay, I didn't write it all down. That's the first blank. The second blank is 2.94 times 10 to the 16. Okay. All right, that is first blank, second blank. Next problem is going to be in parenthesis, 2, 4, -4. That's your x, y, and z. We've done one of those in the previous video. Factoring in the second form, you've got xm to the 5th minus 2py squared in the first binomial here and here, and then the other 3 terms are written here. X to the x squared, that's a 2, m to the 10th plus 2x m to the 5th py squared plus 4p squared y to the 4th. And this is the order in which it is written in the answer key. So you don't have to worry about alphabetical order or anything like that. This is the way it is. The next problem, number 15 on my page, the graphing one. You're going to circle the -5 and go to the left, circle the +2 and go to the right. Last problem, we're factoring for solving for x by factoring the 4/3 and -2. It doesn't matter which blank you put it in, it's going to take it in any order you give it. That's all for lesson 115. We only have 9 more lessons. It's about 5 or 6 more videos, and then we're done. Okay, sweetheart? So, plug in those answers. You've done all these problems before. This is not anything new, so I don't have I don't feel bad about helping you, just giving you the answer. I know that you know how to do them. This is just busy work at this point for these particular problems. In the next lesson, new problems will work out. This busy work, I'm just going to go ahead and let you get through it, okay? All right, but I do, I know that you know how to do them, so I do expect you to do well on the final exam. And that's all I've got for now, and I will see you in the next video.